Hi, good evening everyone. I'm Abram, I'm the Technical Support Manager for Ultimaker here in the UK and Ireland. I'm going to flip everything on its head and stop talking about drones for a minute to talk about 3D printing, and I will segue back into drones and hopefully an inspiring case study in the end. So, I'll just tell you a little bit about myself. I've been with Ultimaker for 3 years. I joined them after building my first Ultimaker original, and around the start of the launch of the Ultimaker 2. Ultimaker developed over in Holland. It was developed from the RepRap project. I'm sure many of you know what that is. But essentially it was an open source project for 3D printing. The founders thought that they could make the RepRap printer print better quality prints. I'm sure if any of you have printed with a RepRap, that is quite a challenge. They managed to do that with the Ultimaker original, and essentially accuracy was brought to FDM 3D printing. We could print down to a quality of 20 microns. But the Ultimaker original wasn't particularly reliable. The machine itself was reliable, but it needed a lot of tinkering, and it was limited by the amount of materials you could use. So, along with our, at the time, 10k community members, essentially we introduced reliability, speed, and a whole host of new materials to FDM 3D printing. So, the development of the two led to industrial applications. So a lot more professionals got involved, and we also listened to their comments, which essentially led to the Ultimaker 2 Plus, and that increased reliability even further, and the quality of the prints. If any of you have seen them, I mean, they speak for themselves. Well, this one's not doing the best. Which led us to a new machine at the end of last year. So, I'll leave it there. I'll introduce the new machine to you slightly later on. The sort of climate around 3D printing at the time we launched the Ultimaker 3 had gone from heavily focused on the maker community to 80% of our customers now are business customers. So, with that in mind, we had to think about Industry 4.0, so we went from just using a SD card in the machine and it was standalone, to essentially Wi-Fi capabilities, connectivity, and also a camera in the machine, so you can do a lot more things remotely now with the machine, which is great. So, how is the Ultimaker being used? We've gone from a rapid prototyping device, which was considered pretty much 100% rapid prototyping, to now rapid prototyping is still the biggest application for the machine, but we are also seeing massive movements towards rapid tooling, in some instances rapid manufacture, and for all you guys in here, lessons is up there. Education is a massive market for us. The advanced tax base that you have here has multiple Ultimaker machines that you can go and use. Hopefully I'll inspire you to go and use them after this talk. But we can break this down further. It's not just rapid prototyping, what would traditionally be a concept model, just a model for a visual aid. It's now moving to functional prototyping, so functional fit testing, things like that. Also the tools. And the tooling they're used for jigs, fixtures, patterns, moulds, castings, and the really interesting part is the end of use parts. Essentially, bridge manufacture, low volume production, custom made parts, and end of life parts are all being produced on the Ultimaker for various different products in various different industries. Cool. So this has led to the Ultimaker 3, the machine in front of you. The biggest advance for us with the Ultimaker 3, we wanted to release it for the Ultimaker 2 Plus, but it involved a lot of the things I'm going to go into now. Essentially, it allows you to print reliable dual extrusion prints with water-soluble supports. So there are a lot of machines on the market that are able to print dual extrusion. Most of them require some sort of chemical to get rid of the support structure. What you need for our supports is H2O. And it's a fantastic improvement. We've also increased the accuracy of the machine, which has been done through a complete redesign of the hot end. Essentially, there are cartridges now for the hot end. Replacing the hot ends on our own machines would take an experienced user about an hour, and these just clip in and clip out. So certainly for maintenance and reliability of your machine, it has dramatically increased again with the release of the Ultimaker. So, in order to make advancements in materials, we needed to be able to increase the heat of the nozzles. When there's two nozzles together, there's a heat transfer. And also, on our earlier machines, there was a lot of heat going back up into the nozzle and into the delivery system, which meant that we had to limit the heat that we could print on our previous machines. So with the redesign of the print cores, the cartridges, came a double heat break and a better cooling system for the machine, so we can now achieve temperatures of 300 degrees where we could only do 260 before. Essentially that means that we can print with more materials, and obviously that's much better for quality of your final prints, and especially if we want to use it for something functional afterwards. We have a lot of developments in engineering materials that have helped us create real functional prototypes. So the system is easy to use, higher uptimes, there's more control over the cooling process, and the higher accuracy has been received. Essentially, one of the difficulties with dual extrusion printing was the delivery method. A lot of dual extrusion machines rely on you to have a very good sense of how to calibrate the machine. We have developed the two nozzle system, so there's a lifting process. You can probably see the machine here keep going to the back corner, and it changes the nozzle, which is further down, and the nozzle which is printing. So effectively we can transfer the high quality of prints down to 20 microns that we had on the old machine, but do it with the dual extrusion, which is one of the problems that some of the other machines face. So now when people come and ask me, oh, you can print anything with these, or can you print anything with these machines? And I used to have to say, well, within reason, you have to consider the geometry, you have to work with the models. Now you can print any geometry. It's absolutely fantastic. So I'm going to give you 3 real-world examples just so that you can see how this is actually applied in the real world. The first one is the ABB robotic arm. The development costs for the fingers of their arms through the traditional methods would take 2 to 4 weeks. It would cost them $450 per part, and they'd get one test done per month. After introducing the Ultimaker, they can produce a part in 1 to 4 hours. The cost of the part, which includes engineering costs, so really that cost is just the cost of the engineer, is $75, and they can produce 5 to 6 iterations each month. So their productivity is increased 6 times by introducing the Ultimaker technology. The second case is Tucci hot rods. They make aftermarket parts for cars. If you're into souping up your cars, then they make some cool products. The one that was taken as an example was a headlight that they designed for Ford Focus Focus STs. You can see on there that they had two methods of getting these final production parts, and these are final production parts that have been made on the Ultimaker now. They could either make them through traditional model making, so they'd get somebody to actually physically make it, and it would be done within 48 hours, but it would cost $3,000 per part. Their preferred method, if they had time, if they didn't have to be agile, then it would cost them $500 per part, but that would take 3 to 4 weeks. When they introduced the Ultimaker printers, they can produce one part in 12 to 24 hours, and essentially it costs $15 to $17 per part. So, to bring this back around to the talk on drones, I'm glad that nobody else has mentioned this in any of the previous talks, which were absolutely fantastic, by the way. We have a humanitarian aid project. It was launched on Kickstarter by a gentleman over in Holland, and he was requesting 70,000 euros to get the project off. I think it's up to 180,000 now. So he's well on board and moving along with this project. But essentially it's the Minecraft drone. So his quote is that there are over 100 million landmines worldwide. Every day, more than 10 civilians die due to these mines. And essentially, there are more than 1 billion people living at risk. There is mainly 60 countries where these mines are still in place after wars, etc. So, mine sweeping traditionally is thorough, it's costly, it's time consuming, and it's very, very dangerous. So, the Minecraft project is there to stop the human element, or the animal element. In some instances they use animals to do the minesweeping. So, how do they do that? With the Kafon drone, they can map, detect, and detonate drones. Essentially, they say, mines, sorry, just blow up the drones. Essentially, they send the drones over to a mapping, they take aerial photography, they analyse the aerial photographs, they highlight where the drones are, they put a GPS flag on each of the drones, and then they send the drone with a robot arm on it to put little detonators on the drones, and then they can detonate any mines without injuring anybody or anybody being anywhere near the site. So, my talk is very short. I hope I have inspired you into a different angle on some of these things. And you have access to a lot of the Ultimaker printers, so I would love to hear of any projects that have come out of here and you've been able to apply the 3D printing technology.